Hey, Chris Matthew here, founder of Compute Sync. Imagine for a moment if everything around you, everything in the world could connect, communicate, and compute together seamlessly. What could you do with all of that computing power? Well, look around you. Your computer that you're working on right now, if you go to the activity monitor, it's 90% idle even with you working on it. If you look around at all of the servers and workstations in your organization, same thing. Even if they're fully optimized VM servers inside of racks, they're at least 40% idle. Also, we're facing this explosion of IoT devices coming to market. In fact, 50 billion IoT devices coming to market by 2020. All of those devices are mostly idle. They're standing by waiting for an event to happen to do something. Or perhaps they have a sensor attached to them and they're chirping every 15 minutes with temperature sensors. Most of these devices have very powerful Raspberry Pi level systems on chips inside of them. I mean, Raspberry Pis are like $5 for a single core, maybe $30 for a quad core. There's so much excess computing power in the world. So our mission at Compute Sync is to harness all of this idle computing power. That's GPUs, CPUs, all the compute of every disparate device in the world. Laptops, workstations, servers, VMs, IoT devices, mobile devices. Even think about the world of driverless vehicles and smart city applications. We're going to harness all of that computing power to create a public mesh supercomputer. Think about that for a moment. We've been heads down at work for about 3 months now, stealth mode, writing code. We've rewritten an entire platform from scratch in Golang that's a decentralized, distributed mesh computing platform. While our big vision is public mesh computers, we're also focusing on private mesh computers for organizations, large companies that have tens of thousands of workstations and servers, again, like I mentioned, mostly sitting idle. They can activate computes in their corporate infrastructures without any additional hardware. Again, I mentioned this is decentralized, where every node on their private mesh network or the public one will automatically swarm together, discover each other, communicate in a peer-to-peer fashion, be able to share files in a peer-to-peer fashion, and compute in a peer-to-peer fashion as if they're a single supercomputer. So that's what we've been building. We've released an alpha version of this several weeks ago, getting a lot of great feedback from it. In fact, one of the alpha companies that have signed up is the University of Wisconsin. They're currently today doing Parkinson's disease research on top of computes. I got an interesting call from a linguistics professor there at University of Wisconsin. Brilliant. She said, listen, I've got these algorithms that she can do early onset detection of Parkinson's disease. And they didn't have the cloud budget or the server acquisition budget, but they had lab computers. So we were able to put computes on their lab machines, and today they're doing tens of thousands of voice file processing, doing Parkinson's disease research in both Python scripts and R scripts on our decentralized private mesh computer. So we have a beta releasing March 31st. Over 500 developers signed up and registered to access this beta. So we're getting closer to being able to introduce and deploy this new beta application of computes inside of dozens of very large multi-billion-dollar companies that want to take a swing at reducing their cloud budgets or maybe running their AI algorithms on the data, on premise, on the edge, wherever the data is located. And only computes can do that for companies as well as for the greater good. looking at how we can utilize this public mesh computing platform to broaden our Parkinson's disease research, cancer research, genetics, genomics, etc. So stay tuned. I'm going to do a series of these videos that walk you through the technology in a little bit more detail, but wanted to explain the vision and what we've been building for the last several months. This is going to be big and it's real, and this technology is only getting faster and more powerful. So stay tuned.